Hi guys, so we are back with lead code question series where we would be understanding various lead code problems in a very brief and concise manner. In case you understand the problems that we discuss in this particular series, do like our videos and subscribe to our channel. So in this particular video, we would be deep diving into the problem that is known as maximum product of splitted binary tree, understand the algorithm, understand the idea behind it, and then finally understand the code structure in a very brief and concise manner. Before getting into the solution of how we are approaching this particular problem, how we are solving it, I would highly recommend you to once go pause the video, go to the problem statement, try to see what the problem was actually, how how it is being dealt with, and how we are trying to get an intuition. So once you get a fair idea of how to solve this problem, what this problem is asking, getting back to this video would make much more sense. Okay, so I'll just brief you around what this problem actually states. So let me take a small example. Let's say we are given a binary tree that looks something like this. So the very first thing that the problem actually wants us to do is split the the binary tree by removing an edge. By removing an edge. So let's suppose we are removing, let's say this particular edge. So our binary tree would now be having two binary trees, that is a two subtrees that would look something like this. Now, the second part is get sum of these two trees. So we can easily find the sum of these two trees. So if we see 5 plus 4, 9 and 2, that would be 11, 11 and 1, 12. Into 9, that would result out to be 108. So this is a third part that says that the S1 sum should be multiplied with S2 and we would be getting some product out of it. The fourth part is out of all possibilities, maximize the product P, and that would be our answer. So in order to get this particular product P, let's first see what are the particular some of the possibilities that could be made with this particular example. So let's take that same example again. And this is the example that is given to us. Okay, so let's try and remove this particular uh, let's try and remove this particular edge. Let's see how it looks like, what it looks like. So if we are removing this particular edge, so if we look carefully, so it would be having a subtree that looks like this, and it would be having a subtree that looks like this. Okay, so now let's do another thing that let's try and remove this particular edge. So how our two subtrees will look like? Subtrees would look like 1, 2, 4, and 5. Sorry, 5 would not be there. My bad. Yeah, so 5 would not be there. And the second part would be that 3 and 6 is also attached to it, and the 5 is the only subtree node that exists as the second subtree. Okay, so once we get to this idea, so what we can understand from this, like if we closely see on this particular part, that is the first part, or I must say the parent tree that is given to us. If we look into it, we tried to remove these two uh, edges from it. Okay, so can we not say that, let's suppose we are standing on a particular node. So we are standing on this particular node. So we can make a choice. Either I can remove this particular edge or I can remove this particular edge. Okay, so yeah, that makes sense that in order to find the answer, we need to remove one of the edges. And we are actually not removing the edges, but we are more into attaching or getting the left and the right subtrees sum, right? So we can easily get what is the uh, left part sum and the right part sum, right? So once we get the sum of the left part and the right part, what is the next thing that we need to do? So over here, until this point, I know what is the sum of my parent tree. My sum of my parent tree was 1, right? So now I have two options. So 2, 4, 5, that gives me 11, and this gives me 9 as the answer. So one subtree would be 1 plus 11. So this is the one sum. And correspondingly, for the same subtree, the sum would be 9, right? The another option that I'm having is either I can have one of the subtree to have a sum as 11, and the second subtree would have the sum as 10, right? So this can be easily calculated if we know what is the sum until the node at which we are taking a decision to remove the left or the right edge. Okay, I'll take another example by removing another set of edge, and let's see the same thing once again. So let's suppose we, sorry, yeah. So let's suppose this was the subtree, and this time we are standing at this particular node. Now, if we are standing at this particular node, what is the thing that we need to keep in mind? Okay, so if somehow we know what is the sum at this particular edge or this particular node, we can easily calculate what will be the sum at the left part and the right part. Okay, so over here, let's suppose right now cannot easily intuitively get what is the sum until this particular node, right? So let's suppose that sum is x. We will get into it, like how we are calculating this x. So x is nothing but this particular sum. I'm referring to b as x. Now, if we closely see what is the left part sum and the right part sum, it says that it is 4 and a 5, right? So we know the left part sum is 4 and the right part sum is 5. Okay, so now we know what is the left part sum and the right part sum. Now let's see how we can calculate this particular x. So let me just brief you around a bit. So let's suppose you know initially what is the sum of the all of the nodes that are present in this particular binary tree, right? So if you know the sum of all the nodes that are present in this binary tree, that is, let's say it is total. If you do minus the left part and the right part, doesn't it mean that you are actually ending up to get the sum x that we actually require to find which particular part, that is the left part or the right part, is to be attached to the final answer to get the maximum product so far. Okay, so if this part is clear, then I think going further would make things a little easier. Okay, so if we have calculated the x at this particular point, so what is the next thing that we would require is, now we have two possible cases. Now x would be getting attached to the left sum, that is this part, this being the first part. So if we are doing this, this basically means that our subtree looks something like this now. And if we are doing x plus right, so this basically means that we have made a sum that most probably, not most probably, that basically looks like this, right? So what if this is the first case, this is the second case, the corresponding left out subtree would be 5 in this case and 4 in this case, right? So I think now we can easily calculate what will be the product of these two categories or these two subtrees that we have obtained from one particular position that we are standing at, that we were standing at this particular position we were standing, and we found out what will be the total um, subtree sum at this particular location. So once we deal with this, then we will be getting to what is the maximum sum for so far. So max would be actually calculated by sum 1, comma sum 2, comma answer maximum, right? Let me just walk you through the code that is there. that I have written for this particular solution. Okay, so if we see, okay, so this was a calling function that says maximum product. So as I said in the algorithm itself, the very first thing would be to get the total sum of the tree that is given to us. Now this helper function is nothing but it is trying to get the sum of the left part and the right part. So you can also say this like it is calculating sum only, but with an additional operation to maximize my answer also. Right. So answer is something that we are finding out, that is the product of the two subtrees that we have obtained. Okay, now getting into the helper function, the helper function I have made a post order traversal. That basically means I will be first calculating the bottommost left subtree sum first, and then right, and then so on and so forth. Okay, so I first calculated the left sum, then the right sum. Now, this sum at node is the very same node that I was talking about. So for example, I am standing at this particular location. So I need to calculate sum at this particular node. Now, sum at this particular node, as we verified, was nothing but total minus left minus right. And the same thing is being done at line number 51. That says that total minus left minus right is something that is at sum at the node. Now, the second option was we had two options. Either we can attach the right sum or we can attach the left sum. So sum at node plus right gives us the consideration for the right being a part of the entire parent subtree. And if we do the same thing with the left part, so we are making left to be the part of the parent subtree. That is the sum at node. Now, in the same manner, we calculated the sum one by considering the right part and the left sum by considering the left part and the right sum. And then finally, we update our maximum answer that we are getting at each and every node. And then finally returning the sum at that particular position by including the sum at node or the node at which we are standing. So this was a very intuition of solving this particular problem. I will surely pin down text file for this particular code. I hope this really helps you. Thank you so much. Bye bye.